On the southern tip of Texas, just beyond the brushland and dunes of Boca Chica, something extraordinary is rising. It's not a stadium or a skyscraper, but something stranger, something that looks like the skeleton of a machine designed to change how humanity moves through space. This is Starbase, SpaceX's launch complex on the Gulf Coast. And in 2025, it has become the heart of the company's most ambitious industrial expansion yet, the construction of a massive new facility called the Gigabay. This Gigabay, an enormous 700,000 square foot structure, is not just another hangar or assembly shed. It's a factory engineered to produce one Starship a day, not per year, per day. The goal, confirmed in planning documents and public statements, is to push output to 1,000 ships annually, a scale never before attempted in rocketry. According to official filings with the Texas Department of Licensing and Regulation, the Gigabay is scheduled to begin construction in mid-2025 and be completed by December 2026. Construction is expected to cost $250 million. At nearly 380 feet high and stretching across an area larger than 10 football fields, the Gigabay dwarfs anything else at Starbase. It will house rows of parallel work cells, each designed to allow simultaneous construction of Starship upper stages and super heavy boosters. With multiple overhead cranes capable of lifting hundreds of tons, the factory is built for non-stop, modular assembly, an aerospace version of Detroit's most efficient car plants. This isn't the traditional one rocket at a time approach that has defined spaceflight for 60 years. It's manufacturing at orbital scale. What makes this development even more remarkable is what's happening just next door. In tandem with the Gigabay, SpaceX is building a dedicated air separation plant to generate its own liquid oxygen and nitrogen on-site, key ingredients in fueling Starship. Until now, these cryogenic propellants had to be trucked in from miles away. But with this new infrastructure, SpaceX can generate and store them on demand, eliminating bottlenecks and cutting down on hundreds of fuel transport trips per year. The permitting for this plant was filed and approved in July 2025. It will span 20 vertical structures over 1.6 acres and is expected to be completed within 8 to 12 months. The proximity to fragile coastal ecosystems required SpaceX to adopt mitigation plans, including restoring nearly 8,000 square feet of native vegetation and closely monitoring nearby sand dunes for erosion. This kind of regulatory oversight has become common at Starbase, where the collision between rapid development and environmental preservation is now a constant negotiation. From the outside, the Gigabay appears to be a single project, but it represents a deep shift inside SpaceX, one that reveals how seriously the company is pursuing its most ambitious goals. Elon Musk has long said that getting to Mars will require more than just engineering a new rocket. It requires building thousands of them. A city on Mars, or even a sustainable lunar presence, can't be launched from bespoke, handcrafted vehicles. It demands scale, reliability, volume, repetition. That's what the Gigabay is about. And that scale is not theoretical anymore. Ground preparation for the facility was spotted in live streams in early summer 2025, with geotextile layers and gravel pads being laid for the foundation. Permitting documents and regulatory filings align with on-the-ground construction timelines. This is real, it's happening, and when it's finished, it will mark the moment when SpaceX transitions from an experimental rocket company to something closer to an aerospace manufacturer with production goals more in line with Ford than NASA. The Gigabay's role isn't limited to Mars. The rockets it produces will also be used for other SpaceX missions. The Starlink constellation, point-to-point, suborbital flights, lunar cargo deliveries, and even military or national security payloads under future federal contracts. And with each ship built at marginally lower costs due to economies of scale, the company inches closer to a world where launch frequency goes up and prices come down, just like the internet infrastructure Starlink itself depends on. It's easy to forget how isolated Starbase once was. Just a few years ago, it was nothing more than a dusty road to a beach, bordered by wildlife reserves and surf. Today, it's a launch pad, a rocket yard, and soon, an enormous factory. The Gigabay is a symbol, not just of SpaceX's ambitions, but of a broader shift in American industrial strategy. Texas is no longer just a state with a rich history in oil, cattle, and football. It is now home to the largest rocket production line in the world. And this is only the beginning. On the wide-open plains of West Texas, near the city of Abilene, a silent revolution is taking shape. Far removed from the high-rises and highways of the big cities, a colossal complex is rising under a sweeping sky, a venture so vast and ambitious, it's been quietly dubbed Stargate. By 2025, this project has moved from whispers to bulldozers and cranes, as the first phase of what is planned to be a $100 billion AI campus breaks ground. When completed, Stargate will be a fortress of computation and cooling, a high-security data center spread across thousands of acres, powered by dedicated transmission lines and backed by on-site water treatment, diesel backup, and a private substation. Media reports and local filings confirm that major partners include Oracle, SoftBank Vision Fund, and venture capital firms connected to OpenAI. Though SpaceX builds machines for interplanetary travel, Stargate builds the engines of artificial intelligence itself, the invisible forces powering smart cities, autonomous vehicles, and the next wave of scientific discovery. Construction began in earnest in 2023, with the excavation of service roads and grading of the site. Massive swaths of land were leveled, revealing the challenge of erecting supercomputing infrastructure in a region prone to flash floods and summer heat. Workers face the unique task of installing miles of chilled water piping, electrical conduits, and emergency power systems beneath the earth. Nearly 200 megawatts of power capacity are expected, equivalent to a mid-sized city's demand. So, utility-grade transformers and cooling towers have already begun to rise. What sets Stargate apart is not its scale alone, but the precision and engineering rigor required. Air and water filtration systems are being installed to meet Tier 4 data center standards, meaning zero downtime and fault tolerance across every infrastructure layer. That requires redundant power loops, backup diesel generators, and on-site water recycling capable of processing millions of gallons per day. Piping networks now snake under the earth, linking building cores with chilled water systems designed to keep racks of AI processors humming at optimal efficiency, even under scorching Texas sun. And yet, it's not just bricks, steel, and wires. Stargate's planning documents also reveal environmental protection efforts. Stormwater basins built to contain the first few inches of rainfall, habitat corridors set aside for local wildlife, and landscaping plans that include thousands of native grasses and shrubs to combat erosion. In a region known for its stark terrain, planners have worked with ecologists to sustainably blend infrastructure with the land. The first cluster of buildings is expected to come online in late 2025, supporting training and inference operations for large language models. While the full campus is rumored to expand into a $500 billion AI and computation megacenter, public plans remain vague, perhaps intentionally so. Stargate's vision is clear, however. Texas is staking a claim in the AI revolution. With every megawatt of power, every cooling tower, and every square foot of raised floor, the campus lays bricks in the foundation of a digital future. For engineers and architects, Stargate is a puzzle of scale and precision. Foundation slabs thicker than those used in commercial skyscrapers are poured to support massive electrical transformers. Buildings are designed to withstand seismic events and extreme temperatures. And every hole turn features vibration-damped raised floors, anti-static flooring, and fire suppression systems that whisper a single thought. This is not just computing. This is computing at industrial scale. But Stargate's impact extends beyond the machines. Its construction is changing the local economy, thousands of jobs generated during the build-out, demand for housing and services in nearby Abilene, and millions in property tax revenue dedicated to schools and infrastructure. Local officials are already planning upgrades to highways, water mains, and community facilities to support the influx. And as the campus begins operations, it will bring a steady stream of engineers, data scientists, and support staff to a region that has long sought new industries. Despite its scale and ambition, Stargate faces its own challenges. The region is energy hungry, and securing reliable power requires coordination with Texas's electric grid operators and risk planning for rolling blackouts during heat waves. Water supply, needed not just for cooling, but emergency fire suppression, is also under scrutiny in a state known for droughts. To address this, planners have built deep wells and water recycling systems, yet critics say this may only kick the can. Others question the environmental footprint. To some, Stargate may appear almost dystopian, a thirsty, humming city of servers in the dusty Texan plains. But for proponents, its construction heralds a new chapter in American technological leadership, a place where the physical and digital realms merge, forging the infrastructure that will underpin everything from climate modeling and drug discovery to language translation and driverless transport. By winter 2025, the first phase of Stargate will stand as a monument to scale, an entire industrial network devoted to turning electricity into intelligence. And as cranes continue to turn and concrete cures under the West Texas sun, one fact becomes increasingly clear. Texas isn't just building machines to leave Earth. It's building the data centers that will shape how we live on it. Just outside Austin, in the quiet city of Taylor, Texas, the landscape is transforming. Flat pasture land and farm fields have given way to a construction zone the size of a small town. Tower cranes rise in clusters. Graders and earth movers shift thousands of cubic yards of soil each week. At the center of it all is a single structure, massive, geometric, and still only partially formed. But by the time it's complete, this will be one of the largest semiconductor manufacturing sites on Earth. Samsung's Taylor Megafab. Announced in late 2021, this factory is more than just another chip plant. It is a strategic project, backed by over $40 billion in investment and fueled by rising global demand for advanced microchips. Samsung chose Taylor over sites in Arizona and New York because of Texas's strong utilities infrastructure, tax incentives, and its proximity to Austin's existing tech ecosystem. The site will produce some of the most advanced semiconductors in the world, essential not only for smartphones and laptops, but for cloud computing, artificial intelligence, and even military applications. Construction officially broke ground in 2022, but the real scale became visible in 2023 and 2024. Workers have excavated millions of cubic feet of dirt to lay utility tunnels and foundation pads. By mid-2025, the main fab facility is more than halfway complete, a cleanroom structure that will eventually span over 1.1 million square feet, with state-of-the-art photolithography and wafer processing equipment inside. The cleanroom itself is designed to operate at ISO Class 1 standards, fewer than 10 particles per cubic meter, making it one of the most controlled indoor environments in the world. But the Taylor site is far more than a single cleanroom. The full build-out includes a multi-building campus, administrative headquarters, testing labs, utility facilities, power substations, cooling towers, and on-site water recycling plants. It will have its own rail and road logistics center, along with new transmission lines connecting it to the ERCOT grid. Samsung has worked closely with the Lower Colorado River Authority and the Texas Commission on Environmental Quality to ensure that the site's water and energy usage can scale without impacting surrounding communities. The numbers are staggering. Once complete, the fab will draw up to 300 megawatts of power, use millions of gallons of water daily, and employ over 4,500 workers, not including the thousands of contractors and suppliers who will support operations. To meet its cooling needs, Samsung is building massive heat exchange loops and on-site water recycling systems that will reduce net consumption by up to 75%, a critical factor in drought-prone Central Texas. And the scale doesn't stop there. In April 2024, Samsung announced that it would expand its Taylor investment to $40+ billion, including the addition of 2 more fabs by the early 2030. These second and third fabs will produce advanced 2-nanometer and 3-nanometer chips, semiconductors small enough to fit billions of transistors on a fingernail-sized wafer. This places the Taylor facility at the cutting edge of global chip production, rivaling plants in South Korea and Taiwan. The strategic importance of this megafab can't be overstated. As the United States seeks to reduce its dependence on foreign-made chips, particularly from Taiwan, facilities like Taylor are part of a national security strategy. The project is supported in part by the CHIPS and Science Act, with Samsung expected to receive billions in federal incentives and tax breaks in exchange for building resilient domestic supply chains. According to filings with the U.S. Department of Commerce, the Taylor Fab is one of the largest private sector investments ever made in a U.S. tech facility. Locally, the project is already transforming Taylor, once a small agricultural town of around 17,000 people. It's now bracing for rapid population growth, rising home values, and infrastructure upgrades. Williamson County has invested in expanded roads, wastewater systems, and emergency services to meet the influx. Taylor ISD is working with Samsung to establish STEM partnerships and job pipelines for local students. This isn't just a plant, it's an anchor for a new economic zone. Yet with growth comes tension. Critics warn about rising rents and displacement, the long-term strain on water supplies, and the reliance on foreign labor and equipment for fab assembly. But for Samsung, the Taylor facility is a statement that the U.S. will be part of the global semiconductor future, not just as a consumer, but as a builder. By the end of 2026, the first phase of the Taylor Megafab is expected to begin operations, with full-scale chip production underway by 2027. At full capacity, it will produce tens of thousands of wafers per month, each one containing countless processors that will power smartphones, data centers, and AI models worldwide. From what was once farmland, Texas is now growing something very different, the building blocks of the digital age. Along the Texas Gulf Coast, where the land meets the sea in long industrial corridors, a new kind of energy empire is under construction. While oil rigs and refineries have long defined this region's identity, today's projects reflect a different kind of energy race, one built not just on petroleum but on liquefied natural gas, or LNG. And nowhere is that transformation more visible than in the massive LNG terminals rising from the shoreline. These aren't just export facilities, they are entire industrial cities, equipped with towering cryogenic tanks, loading berths for massive ocean tankers, and intricate systems of pipes, compressors, and control rooms. Together, they're turning Texas into the largest LNG exporter in the world. One of the most ambitious of these projects is Rio Grande LNG, located at the port of Brownsville. Developed by NextDecade, this $18.4 billion project began construction in 2023 and will, by 2027, become one of the largest LNG export terminals in the Western Hemisphere. The first phase includes 3 liquefaction trains, massive systems that supercool natural gas to minus 260 degrees Fahrenheit, condensing it into a liquid for efficient export overseas. Each train will produce 5.4 million tons of LNG per year, with the full site eventually hosting 5 trains capable of delivering more than 27 million metric tons annually. The gas will be piped from the Permian Basin, hundreds of miles inland, through a series of high-pressure transmission lines. Once at the terminal, it's purified, cooled, and stored in full containment cryogenic tanks, some over 200 feet tall, before being loaded onto tankers for export to Europe and Asia. Just up the coast in Corpus Christi, Cheniere Energy is completing an expansion of its Corpus Christi Stage 3 project. Valued at $8 billion, this extension adds 7 mid-scale liquefaction trains, each smaller than the megatrains in Brownsville, but more modular and efficient. Once online in 2026, the Corpus Christi terminal will become the second largest LNG export facility in the United States, behind only Sabine Pass in Louisiana. Together, these terminals are part of a strategic pivot. As Europe seeks alternatives to Russian gas and Asia increases its demand for stable, long-term energy supplies, Texas LNG has become a geopolitical asset. By 2025, the state will export over 15 billion cubic feet of natural gas per day, enough to power entire nations. This rise has prompted over $60 billion in infrastructure investment along the Texas coast, including new pipelines, compressors, ship berths, and worker housing. Engineering these projects is a massive undertaking. LNG terminals must meet extreme safety standards, withstand hurricanes, and operate at cryogenic temperatures without failure. That requires specialized materials like nickel steel and the vacuum-insulated piping, and control systems capable of detecting even the smallest leaks. Many terminals also include flare towers that burn off excess gas during startup and shutdown phases, rising like chimneys above the industrial sprawl. At the heart of every terminal are the liquefaction trains themselves. Each is a multi-story structure of compressors, heat exchangers, and turbines that run 24/7. In Brownsville, they are powered by gas turbines derived from jet engine designs, each one capable of producing tens of thousands of horsepower. The challenge lies not just in building them, but keeping them running with zero downtime. Even a single hour of failure can cost millions in delayed shipments and lost contracts. But these projects are also changing the communities around them. In Cameron County, where Rio Grande LNG is based, Next Decade estimates the project will create over 5,000 construction jobs, hundreds of permanent roles, and inject more than $30 billion into the local economy over 30 years. New housing developments, schools, and port upgrades are already underway, transforming a historically underserved region into a critical node of global energy supply. The projects are not without controversy. Environmental groups have raised concerns about the impact on coastal wetlands, endangered species, and greenhouse gas emissions. While the terminals promise to offset dirtier coal in foreign markets, they also add significant methane emissions at home. In response, companies like Next Decade have pledged to build carbon capture systems into their operations. The Rio Grande terminal will include a system to capture and sequester over 5 million tons of CO2 annually, a first-of-its-kind integration for a major LNG export site. These carbon initiatives are part of what Texas leaders are calling the clean LNG transition, a strategy to decarbonize natural gas at the source and maintain U.S. leadership in global energy markets. Whether this model can scale remains to be seen, but the infrastructure is already being built. As we move further into 2025, tanker ships the size of skyscrapers now glide into newly dredged ports, load up on liquefied gas cooled to the temperature of deep space, and set off across the Atlantic or Pacific. And from Brownsville to Corpus Christi, the skyline isn't filled with office towers. It's filled with the vertical silhouettes of tanks, flares, and pipes, working together in silent orchestration. This is Texas's new energy frontier, not just fossil fuel, not yet fully green, but vast, strategic, and built to shape the global flow of energy for decades to come. In a state famous for its sprawling highways and pickup trucks, the idea of high-speed rail once seemed out of place. But now, after years of false starts and political gridlock, Texas may finally be on the verge of a transportation breakthrough. Across key corridors, a quiet but determined effort is taking shape, an effort to connect the state's booming cities with fast, efficient, and futuristic rail. At the center of this vision is the long-awaited Dallas to Houston high-speed rail project, an idea that has hovered on the edges of possibility for more than a decade. The plan, to build a 240-mile line between the two major metros, reducing travel time to just 90 minutes aboard Japanese-built Shinkansen trains, capable of reaching 205 miles per hour. The route would begin in Dallas, cut through Brazos Valley, and terminate in northwest Houston, serving a corridor that today handles over 16 million car trips per year. After years of delay, the project found new momentum in 2023 when Texas Central, once the lead developer, partnered with Amtrak to revitalize planning and explore federal support. In August 2023, the Federal Railroad Administration, FRA, confirmed it was working with both companies to update environmental approvals and assess grant eligibility. In early 2024, the FRA awarded $500,000 in corridor planning funds through the Corridor Identification and Development Program, a small but meaningful signal that the federal government sees the line as viable. In June 2024, the partnership reached a turning point. The U.S. Department of Transportation, under the Bipartisan Infrastructure Law, included the Texas High-Speed Corridor among several nationally designated rail development zones, making it eligible for multi-billion-dollar funding under the federal-state partnership for intercity passenger rail. While final design and land acquisition are still in early phases, the line is now being modeled on the successful Japanese Tokaido Shinkansen, with Texas Central's original agreements with Central Japan Railway Company, JRC, still in place for technology licensing and operations. But the Dallas-Houston line isn't the only track being laid for Texas's rail revival. Just 30 miles north of Austin, the Texas Department of Transportation, a TXDOT, is exploring a regional rail corridor that would connect Austin, San Antonio, and possibly Dallas through a mix of upgraded Amtrak service and dedicated high-speed tracks. These feasibility studies, quietly underway for years, are now being accelerated with support from regional metropolitan planning organizations and state lawmakers eager to ease the strain on E35, one of the most congested highways in the U.S. The potential benefits of these rail projects are massive. They could cut greenhouse gas emissions, reduce highway fatalities, and relieve traffic congestion along the I-45 and I-35 corridors, two of the fastest-growing urban regions in America. According to a 2022 study by Texas A&M Transportation Institute, replacing even 10% of car trips on these corridors with high-speed rail would save over $1.5 billion annually in fuel, accident costs, and lost productivity. And there's growing political support as well. In 2024, the Texas legislature passed a resolution urging the federal government to prioritize high-speed rail funding in the Lone Star State. Meanwhile, public sentiment has shifted. A 2023 poll by the University of Houston found that nearly 70% of Texans support high-speed rail between major metros if it reduces traffic and emissions, even among traditionally skeptical rural counties. Still, the road, or track, ahead is complex. The original Texas Central project faced fierce opposition from landowners along the proposed right-of-way, many of whom opposed eminent domain. Environmental concerns remain as well, particularly around wetland crossings and wildlife corridors in Brazos and Grimes counties. To address these, Amtrak and TXDOT are planning additional impact studies and stakeholder consultations throughout 2025. Then there's the matter of cost. The Dallas-Houston line alone is expected to cost between $20 and $25 billion, depending on final design specifications and land acquisition prices. That's more than triple the cost of a typical interstate highway project of the same length. But proponents argue that, unlike roads, high-speed rail doesn't just move people. It catalyzes real estate development, reshapes commuting patterns, and boosts long-term economic growth. Cities like Dallas and Houston have already begun zoning adjustments and transit-oriented development plans near the proposed terminal stations. By mid-2025, Amtrak and its Texas partners expect to submit their full project development proposal to the FRA for review. If approved, design and land acquisition could begin as early as 2026, with construction starting before the end of the decade. And while skeptics remain, there's a growing sense that, this time, Texas high-speed rail may finally leave the station. In a state built on speed, from oil booms to digital startups, the idea of riding 200 miles an hour above the flat Texas plains doesn't seem so far-fetched anymore. Whether it's business travelers, students, or tourists, millions of Texans stand to benefit. And if successful, the project could serve as a blueprint, not just for Texas, but for the entire American South.